Hello, everybody. Good evening. Is my audio and video clear? Okay, great. Yeah, so let's get started. Today's topic is going to be triangles. So we are going to discuss all the properties that we have done in triangles, and I'll be taking suitable examples along with those properties. And as usual, towards the end, we'll be taking up CAT questions. So this is what I'll start with. Definition of line, ray, and line segment. Obviously, I'm not going to spend too much time explaining what is ray, what is line, and what is line segment. I hope everybody has basic level of understanding, but let's just go through these things quickly. So what exactly is a line segment? You are joining points A and B. This is what you call a line segment, which will have a definite length. Okay. Now, this is what you call a ray, right? Ray will have a point of I can say this is starting point or origin of the ray, right? And on the other side, it is extended till infinite. And this is what you call a line, which is extended till infinite on both the sides, right? So this is what line, ray, and line segment mean. Now, what about parallel, perpendicular, intersecting, and coincident lines? Okay, so if two lines have one point of intersection, they are called intersecting lines, right? If they do not have any point of intersection, they are said to be parallel lines, right? Perpendicular lines will, again, nothing but one version of intersecting lines only. So these are perpendicular lines, which is as good as intersecting line. The only difference is at the point of intersection, the angle over here will be a right angle, right? What is coincident lines? So if you have two lines which exactly overlap on each other, like this is your L1 and this is your L2 as well. So L2 is completely overlapping on L1, which is what you call coincident lines. Okay. What about angles? So angle is something which is created by two rays starting from the same origin, right? So you have two rays, OA and OB, which are starting from the same origin. This is where they create angle between them, right? Now, angles are of different types: acute, right, obtuse, straight, reflex, and complete, right? What is acute angle? Angle less than 90 degree is acute. This is where it is exactly equal to 90. This is greater than 90. This is equal to 180. This is more than 180, but less than 360. And this is greater than 180. This is greater than 180, less than 360, and this is equal to 360, right? This is how the classification of angles look like. What about complementary and supplementary angles? So for complementary angles, sum should be equal to 90 degree. Supplementary angles, summation should be equal to 180 degree, right? All this is very basic stuff, and people should be familiar with this, right? Now we'll discuss angles which are formed by intersection of two lines. So if you have two lines, suppose there is L1 here, there is L2 here. These two lines are intersecting at a point P. At the point of intersection, we are looking for two different types of pairs of angles, right? One is the pair of angles which are placed opposite to each other, the angles which are placed opposite to each other. And second is the angles which are placed adjacent to each other. Now the angles which are placed opposite to each other, so look at this. This is one pair, isn't it? And this is the other pair, right? So I can say there are two pairs. These angles, measurement wise, they are equal. And the nomenclature of these angles, which are visible opposite to each other, is known as vertically opposite angles. VOA, vertically opposite angles, right? Now, when the angles are placed adjacent to each other, I can create four pairs. Have a look at this. Suppose if I mark these angles as, let's say, X, Y, Z, and W. So my one pair of adjacent angles can be X and Y, right? Second pair of adjacent angles will be Y and Z. Third pair of adjacent angles will be Z and W. And the fourth one is going to be W and X, right? So there are 4 pairs. And these angles, now look at X and Y, what will happen? You will be able to see that when you combine these X and Y, they will end up making a straight line. And when you know that whenever there is a straight line, the angle on the straight line will be 180 degree, right? So you can say that X and Y are supplementary of each other, because when the angles are supplementary, the summation has to be 180, right? So you can say that these angles are supplementary to each other. Okay. And the nomenclature here is angles on linear pair, or you can say angles of linear pair. Why they are called angles of a linear pair? Because they make a straight line. 4 pairs, supplementary. Over here you have 2 pairs and equal. So these are the angles which are created by intersection of 2 lines, right? Now let us talk about angles formed by 2 parallel lines and a transversal. So I'm going to shift this discussion to the next slide. 2 parallel lines and a transversal, right? Over here I'm looking at mainly 3 types of angles. In all these diagrams, L1 is parallel to L2, right? L1 is parallel to L2. And this line, let's call it T. T is known as transversal, which is nothing but a line which cuts L1 and L2 at one point each, right? Now over here, we are looking for 3 different pairs of angles. One is pair of alternate angles. Second is pair of corresponding angles. And third is pair of, I can say, interior angles on the same side. It is pair of interior angles on same side of transversal. Okay. Now let's first try and understand the shape of each of these angles. Alternate angles will be visible in this kind of a Z shape, right? Whenever you get this kind of shape, it will form an alternate angles pair, right? So in our diagram, are we able to spot the Z shape somewhere here? Correct. And the angles which will be enclosed over here is, this is one pair, okay? And if you take this, mirror image of the Z shape, something like this, you will get another pair. This is the second pair, right? So these are your pairs of alternate angles, right? This is the shape. These are the number of pairs. And angles of alternate pairs are always equal to each other. Now, when I say equal to each other, that means if, let's say, this angle is 70, the angle in the same pair, the other angle in the same pair is also 70. This is how they are equal angles, right? The next one is pair of corresponding angles. So what kind of shape will they have? They will have this kind of F shape. You can also have a mirror image of F shape. You can have an inverted F shape like this, right? So many variation of this is possible, but this is how the shape will basically look like. Okay. Can we spot these angles in the diagram? I hope you are able to see this F shape here. Okay. Now, when you make the angles along it, this is the pair of corresponding angles, right? These two angles are known as corresponding angles. Now we can make the other angle just above that. Okay, this is the second pair. Same way, we can have 2 pairs on the left hand side. This is the third pair. and this is the fourth pair. So there are 4 pairs of corresponding angles. What about their measures? They are equal. When I say they are equal, I must add this, that if the lines are parallel. Okay. If the lines are not parallel, the alternate angles will not be equal. Similarly, corresponding also will not be equal. Here we have already given that the lines are parallel, and therefore I'm taking all of them as, all the angles of that pair as equal angle, right? So how does this work? Suppose if I have been given that this particular angle here is 50 degree, then another angle in the same pair will also have the equal measure, which is 50 degree, right? The third one is having a C shape like this. It can be a C shape or it can be a mirror image of a C shape, right? How do you spot these angles? These are the interior angles on the same side of transversal. You can even match with the description over here. They are interior, which means lying between the lines. Okay. And they are on the same side of the transversal, right? So both these angles are between the parallel lines and therefore in the interior region of the parallel lines, and they are on the same side of the transversal, right? So this is one pair and this will be the other pair. Number of pairs, 2. What about the measures? These angles are supplementary. If the lines are parallel. L1 parallel to L2. Now on straight line, you can make 2 angles. Then those angles are known as a linear pair, right? So there is one question which says that, can we say straight line is a linear pair? So on straight line, you should be able to draw 2 angles, right? So once you draw these 2 angles, now we can say that these 2 angles make a linear pair, right? Now let's take some questions on this. Okay, before we move on, I will discuss one more thing over here. Uh, let's say these are my L1 and L2. This is the transversal. Suppose if it is given to me that this angle is 70 degree, right? And it is also given to me that L1 is parallel to L2. With the help of this information, I will be able to find out the remaining 7 angles, right? How do we do that? So first of all, I can say that this is the vertically opposite angle of 70, correct? Which is equal, and therefore this is also 70. Then I can say that this is linear pair of 70, and therefore this should be supplementary, so it should be 110, right? Similarly, this is vertically opposite of 110, hence it is 110, right? Now we can take any one from these 3 angles, which is either an alternate or corresponding, or this thing, interior. Okay. Now, if you suppose take alternate pair, you can make a Z shape like this, and these are the 2 angles of that alternate pair, right? According to what we discussed in the previous slide, is angles of alternate pair should be equal. So if this one is 70, this has to be 70. And then again, you can say that this is vertically opposite of 70, this is linear pair of 70, and this is also vertically opposite of 110, right? So only 2 measures are possible, which is 70 and 110. Now we can check all the remaining information. That is, if you look at corresponding angles, if you try making F shape like this, you will be able to notice that your corresponding angles are equal, isn't it? 110 and 110, they are equal. Also, if you make a C shape over here, you will be able to see that your interior angles on the same side of transversal are supplementary, which is 70 and 110. The total will be 180. How do we get 110? So because you have 70 as one of the angle here, right? This has to be supplementary of it because you have a straight line. On straight line, you have a linear pair, which means angle of 180. So 180 minus 70, the remaining is 110. Yeah, this is the previous slide. Let's look at the next question. In the adjacent figure, PQ is parallel to RS. So this is the first thing we have to note. PQ is parallel to RS, right? I'm going to highlight the parallel lines with the same marker. So this is PQ. This is RS. Because I've used the same marker, that is indication that the lines are parallel. PQT is 20, which is visible in the diagram. TSR is 25, which is also given. We have to find out QTS. So what we can simply do over here is that we can extend this line QT and make it intersect this line somewhere here, right? This point may not necessarily be R, but it can be any other point of intersection as well, right? Now over here, can we say that because this makes a Z shape? Can you see that? Sorry. This makes a Z shape. Okay. And over here, because the lines are parallel, you have alternate angles. So those alternate angles will be equal. And therefore, you can say that if this was 20, this must be 20 as well. Correct. So this is 25 and this is 20. What is the total here for these two angles? It is 45. If this is 45, can we find out this angle, which is 180 minus 45? Right. What I've done is I've used the simple property that sum of three angles of a triangle will be 180. So from 180, if I subtract 45, this is going to be 135. And if this is 135, can I say that this has to be 45 again? Because these two angles will be making a straight line. So 180 minus 135, you can say this is 145. If you know the property of exterior angle, you can straight away say that because two of the angles in the triangle are 25 and 20. So the exterior angle has to be sum of two other interior angles, which is nothing but 45. So this way also you can derive the same value. Next question. In the adjacent figure, PQ is parallel to RS. This is PQ parallel to RS. These two lines are parallel, which are marked with the same highlighter. MON is 25. MON, this is 25. Now, can you see this symbol here? There are two angles marked with black dot and there are two other angles marked with a white dot, right? So equal symbol obviously stands for equal angles. And therefore, if this is 25, this one has to be 25. Correct. Now I can take these two angles as x each, right? Now can we say that this x plus this 25 and plus this 25 will make a straight line? So I can say 2x plus 2 times 25, which is 50. That is 180. So 2x is 130 and therefore x is 65, right? So I can write 65 in place of x. Now, can we answer these questions? First one is LOM. Okay, so where is LOM? LOM, this angle is 65 and that is the answer. OLN, where is OLN? Okay, so how do we find out this angle? Can we see that this will make a Z shape? Correct. So these two are alternate angles, and they are alternate angles made between the parallel lines also. So if one of them is 65, the other one, which is OLN, is also 65. POM. POM. Okay. So POM is nothing but the summation of these two. Can you see that? 65 and another 65. So that has to be 130. And the last one is the NOL. So we have N here, O here, and L here, right? So NOL will be the total of these two angles. Look at this. This is NOL, right? So it's a total of 65 and 25, which is equal to 90. Okay, moving forward with theories of triangle, sum of interior angles. So this is your triangle. When you try to draw a triangle, please do not make an equilateral triangle, because when you draw an equilateral triangle in order to solve any question, you may tend to take some unnecessary assumption, which may be only applicable for equilateral triangle, right? So general practice will be try to draw something like this so that you may remind yourself that it is not equilateral, and hence you will avoid those unnecessary assumptions. Sum of interior angles, that is A plus B plus C, and that is 180. Sum of exterior angle, that is exterior A, this is exterior B, and this is exterior C. I can say sum of exterior is 360. Each exterior angle is equal to sum of two remote interior angles. So this can be written as, let's say for example, if you have exterior A, it can be written as sum of other two interior angle, which means exterior A is equal to B plus C interior, right? You can also say that exterior B is equal to A plus C and exterior C is equal to A plus B, right? In general, any exterior angle is equal to sum of other two interior angle, right? Now, this is the third property. This is the next property of triangle, which is important when it comes to the measures of the side, right? So sum of two sides of the triangle should always be greater than the third side will be greater than the difference of the two sides, right? So how does this work? Suppose three sides are A, B, and C, right? So sum of two sides, which is A plus B, will be greater than the third side, that is C, and that is greater than the difference of two sides, which is A minus B, right? This always holds true for any triangle that you have. Yeah, this is previous slide. Let's now discuss some basic questions on these properties that we have seen. Consider a triangle ABC. So I have triangle ABC. Capital ABC are the vertices. Small ABC are the sides. Now, this is generally labeled in a manner that small a corresponds to side opposite to angle A. Small b corresponds to side opposite to angle B. And small c corresponds to side opposite to angle C. This is how it can be generally written, not every time, but most of the time, this is how we follow it. Yeah, if A is 95, A is 95, C is 45, the exterior angle at B. Now we've just seen that exterior B is nothing but sum of interior A plus C. So 95 plus 45, the angle will be 140. That is the answer. And this is where exterior B can be shown. A is 8. This is 8. B is 3.5. How many integer values can C take? We've just seen that sum of two sides is greater than the third side is greater than the difference of the two sides, which means your a plus b will be greater than c will be greater than a minus b. Or it could be b minus a also, whichever is greater, right? Now what is my a plus b here? 11.5 greater than c greater than 8 minus 3.5, which is 4.5. So my c is ranging between 4.5 and 11.5. How many integer values can c take? More than 4.5 if you begin with, then it will be 5, 6, 7, 8, 9, 10, and 11, right? So these are the 7 values that c can take. Consider ABC. Okay, same data. If exterior angle as at A and B add up to 240, find out C. Okay, they are saying that exterior A plus exterior B, right? They add up to 240. What is exterior A? B plus C. What is exterior B? A plus C. This is equal to 240. Now, can we say that B plus A plus C, right? Which is these three angles will add up to 180 because that is sum of interior, correct? So if I write 180 for this, my C is going to be 240 minus 180, and that is 60. In the adjacent figure, find out measure of PDQ. So this point is Q here, and this is what we are looking for, right? You have been given that these two sides are equal, right? AP and AD are equal. Now, the property of triangle, one of the properties of triangle says that angles opposite to equal sides are equal angles. The same is true for angles also. So sides opposite to equal angles are equal sides. Okay, either ways it is true. Now in this triangle APD, just focus your attention on that. Okay, in this APD, can we see that AP and AD are equal sides? And because of that, angles opposite to them will also be equal angles. So I can take these two angles as x each. They are equal, right? So what about the third angle in the same triangle, that is angle A? We know that sum of three angle is 180. Two of them we have already taken as x. So the third angle will be 180 minus 2x, right? Now we can simply replicate the same thing in the other triangle, right? So over here also these two sides are equal, and therefore their opposite angles are equal, correct? So these two angles I'm taking them as y and y, correct? So the third angle of the same triangle will be 180 minus 2y. Now, can we say that sum of three angles of a triangle is 180, correct? So a plus b plus c is 180. What is a? 180 minus 2x. What is b? 180 minus 2y. What is c? That is 90 degree, as you can see. 180 cancelled. So I'm having 180 plus 90, which is 270 on left hand side. That is equal to 2x plus 2y on the right hand side, which means x plus y is 270 by 2, which is 135. Correct. But what is the question? In the question, you have to find out PDQ, this angle, right? So can we clearly see that this makes a straight line? Okay, so these three angles at point D are going to make a straight line, right? And because it makes a straight line, can we say that sum of those three angles which are made at point D will be equal to 180? Which three angles are made here? X plus, this is the unknown that we want to find out. Let's call it Z, plus Y We'll make a straight line. So that's 180. Out of which I already know the value of x plus y. So this plus this is 135 plus z is 180. And therefore z has to be 45. All possible obtuse angled triangles with sides of integer length are constructed such that two of the sides have length 5 and 12. How many such triangles will exist? I think this is what we'll take with the triangles part 2, because so far I have not discussed what is obtuse angle triangle. So we'll just wait for some more time before we discuss this, right? Okay, yeah, I think after this slide we can discuss. So types of triangle based on sides and based on angles. Based on side, the triangle can be classified as a scalene triangle, isosceles triangle, and equilateral triangle. Equilateral triangle is where all three sides are equal, all three angles are equal, and each angle is going to be 60, right? This is how an equilateral triangle looks like. All three sides are equal, all three angles are 60. What about isosceles? At least two sides are equal and their opposite angles are equal. Suppose these two sides are equal, then these two angles are equal. This is known as isosceles triangle, right? Scalene triangle, all three sides unequal, all three angles unequal, right? Now, types of triangle based on angles. So, based on angles, you can have acute angled triangle, obtuse angled triangle, and a right angled triangle, right? Acute angled triangle is the triangle where all three angles are acute. So, if you have three values here, which are all less than 90 degree. Suppose you have a 50, 60, 70. All three angles are acute. This kind of triangle is known as acute angle triangle. Right angle triangle, exactly one is 90 degree. Remaining two are acute. Okay. And remaining two are complementary to each other, because when I say that A plus B plus C is 180, B is 90 already because it's right angle. So A plus C will be 90, and therefore A and C are complementary angles. So in any combination, their total will be 90 degree. Obtuse angle triangle, you will have one of the angle as obtuse, remaining two are acute, right? So this is more than 90. These two will be less than 90, right? Now, one very important thing that you need to remember about these three types of triangle is that a right angle triangle will follow Pythagoras theorem, which goes something like this. Everybody is familiar with this: a square plus b square equal to c square, right? So whenever this happens, where c is the largest side, so whenever this happens, you can say that it is a right angle triangle. Okay. Sometimes if your c square is greater than a square plus b square, okay, c square greater than a square plus b square, then you can conclude that it is obtuse angled triangle. And if your c square is less than a square plus b square, you can conclude that it is acute angled triangle. Every time we are comparing from the point of view of c square, okay, c square we are comparing with a square plus b square. If c square is less, it is acute. If c square is more, it is obtuse. And Pythagoras triplets, at least you should be familiar with these many triplets: 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, right? Everybody should be familiar with at least these triplets, right? I'm not giving you 6, 8, 10 here, because 6, 8, 10 is nothing but 3, 4, 5 into 2, right? So I think you must be knowing this already, that any triplet, when you multiply that with any number, you again get a triplet, right? So 6, 8, 10 is nothing but 3, 4, 5 multiplied by 2, right? If you multiply 3, 4, 5 with 3, you again get a triplet, which is 9, 12, 15. Similarly, 5, 12, 13, if you multiply by 2, you get 10, 24, 26, which also is a triplet, right? So no point remembering the multiples, but at least you should know these basic triplets. Scaling triangle is the triangle whose all three sides are unequal. Next one. No need to use any formula to find out the triplet, right? There are formula, right? But not necessary for you to know at this stage, right? You can simply remember these four and move on. Simple. Okay. Let's look at this question. Consider a triangle ABC. Okay. A is 15. A is 8. Sorry. B is 15. And C is 90. The moment you know this much, that it's a right angle triangle and two of the sides are 8 and 15, right? 8 and 15 should be the sides which are making a right angle, right? If that happens, the hypotenuse here has to be 17 according to the triplet. Okay. Now at this stage, one should be very clear when to use the triplet and when not to use the triplet, right? So every time when I'm giving you 8 and 15, you should not say that the third side will always be 17, because if 8 and 15 are the sides making the right angle, then yes, the hypotenuse is 17. But suppose if I'm giving you 8 and 15 in this combination, this is 8, this is 15, right? Should you say that this is 17 even if I say this is right angle triangle? No, because it's not possible that 15 is your hypotenuse and it is shorter than the other side. Correct. So 8, 15, 17, 17 has to be the hypotenuse. If 15 is the hypotenuse, then triplet is not applicable. In that case, you should simply use the Pythagoras theorem, and that will give you an answer without any triplet, which is x square plus 8 square equal to 15 square. You should try to solve value of x out of this. Okay. But yeah, here it is triplet because it is given that A and B are 8 and 15 and C is 90. So C is the third side, which is hypotenuse, and therefore it is 17. Find out the hypotenuse of a right angle triangle with perpendicular sides as. Now it is clearly given to you that these are perpendicular sides. Okay. Now 39 is the measure of one side. 52 is the measure of the other side. And I want to find out the third side. So are we actually going to do 39 square plus 52 square is equal to x square? No. What we are going to do is we will try taking something common. So 39 is one side, 52 is another side, and the third side is unknown, right? Let's keep it this way only. Now, what maximum number can we take common out of 39 and 52? We'll be able to take 13 common out of it, right? So just write 13 outside the bracket. After taking 13 common, you will be left with 3 here. You will be left with 4 here. Now you will be able to, enter a value based on the triplet of 3, 4. So third value has to be 5, right? So if this is 3, 4, 5, this has to be the 13th multiple of it, which is 13 3s are 39, 13 4s are 52, and therefore this has to be 13 5s are, which is 65. This is how one can find out the missing number in a triplet. Let's see another example. 25 and 60 are the perpendicular sides. So you can write 25, 60, unknown, right? What can be taken common out of 25 and 60? Obviously, 5 is common. After taking 5 common, I'm left with 5 and 12. What has to be the third side? So I can use the triplet of 5, 12, 13, right? The hypotenuse is 13, and therefore this has to be 5 into 5, 25. 5 into 12, 60. So this should be 5 into 13, which is 65. Yeah, this was the previous slide, and this was previous to previous slide. Find out the smallest side of a right triangle whose larger sides are 45 and 51. This is still a question based on triplet. Okay, this time these are the larger sides given. I need to find out the smallest. So this is the smallest. Then comes 45, then comes 51, right? What can be taken common from 45 and 51? From 45 and 51, I can take 3 common. After taking 3 common, I'll be having 15 here. I'll be having 17 here, right? Now, 15 and 17 are a part of which triplet? They are a part of 8, 15, 17, right? And therefore, this missing value has to be 8. So now I can enter this value. 3 8s are 24, 3 15s are 45, and 3 17s are 51. If the sides of ABC are 5, 7, and 9, 5, 7, and 9, what kind of triangle will ABC be? Look at the option: acute, right, obtuse, cannot be determined, right? How do we figure it out? Remember, we have just seen the formula. If your C square is A square plus B square, it is right. If your C square is greater than A square plus B square, it is obtuse. If it is less than A square plus B square, it is acute. Okay. C is the longest side. So C is 9 in this case. Let's square 9, which is 81. Compare that with the sum of square of 5 and 7. So 5 square plus 7 square, right? This is 81. How much is 5 square plus 7 square? 49 plus 25, which is 74. So obviously 81 is greater. This is greater. And therefore, can we say this is the case we are having here for this question? If this is the case we are having, then the type of triangle has to be obtuse. If the sides are 6, 8, 9, what kind of triangle is this? 6, 8, 9. C is going to be largest side, which is 9. So I'm going to compare 9 square versus 6 square plus 8 square. This is 81. This is 36 and 64. So that's going to be 100. Now this time my C square is less than A square plus B square, as you can see. Okay, you have less than sign. So if C square is less than A square plus B square, we'll have this case, right, which is acute angle triangle. Okay, so this is how one can determine whether the triangle is acute, obtuse, or right. Okay, now before I go further, I'll solve that question that we left earlier. All possible obtuse angle triangles with the sides of integer length are constructed with the two sides having length 5 and 12. Two sides are 5 and 12, right? And the triangle is obtuse angle triangle. How many triangles will be possible, right? I first need to find out the range of the third side. Okay, what is the range of the third side? A plus B greater than C greater than A minus B. I hope you remember this, right? So 5 plus 12 is 13, is 17, is greater than C, is greater than 12 minus 5, which is 7. So my C is ranging from 8 to 16, I can say. It is greater than 7, so it can't be 7. It is less than 17, so it can't be 17 also. And therefore, C will take up values from 8 to 16. 8, 9, 10, 11, 12, 13, 14, 15, 16. These are the values possible for C, right? Now, we are not yet done because we have to check that whatever triangle we are making, are they turning out to be obtuse angle triangles or not, right? So we already have two of the sides, 5 and 12. Along with that, we are going to take, suppose, 8 as the third side. Now, when you take 5, 12, and 8, what is your longest side? Your longest side is going to be 12, right? So 12 square, you are going to compare with 5 square plus 8 square. Okay, which one is greater? 12 square is greater. So this gives me obtuse angled triangle. Correct. Now let's try with 9. Okay. Now I'm having a combination of 5, 12, 9. Right. 8 is gone. Now we are trying with 9. So 5, 12, 9. Still 12 is the longest side. So again, I'm going to compare 12 square with 5 square plus 9 square, right? So 5 square plus 9 square is obviously less than 144. I don't have to calculate how much exactly it is. I know it is 81 and 25, which is going to be less than 144. This is also obtuse. Okay, so we have tried first two measures. Let's now try the third one. What is the combination this time? 5, 12, 10. 12 is still the longest side. 5 square plus 10 square. This is 125. This is 144. 144 is still greater. Hence, this is still obtuse. Okay. Now, let's try the next one. 12 square, you compare with 5 square plus 11 square. 11 square is 121. This is 25. If you add them, the total is going to be 146. And 144 is less than that. Okay, which means this triangle is acute. Because this is where your c square is lesser than a square plus b square, right? Now I'm going to take the next value, which is 12. So now my combination is 5, 12, 12. 12 is still the longest side. And therefore, I'll be comparing 12 square with 5 square plus 12 square, right? Obviously, I don't need to calculate also because 5 square plus 12 square is always greater than 12 square. So this is also acute. Okay. Now moving to 13, right? Now, as soon as you enter in last four values, that is 13 onwards, right? Your longest side will change. So far, we have been saying that 12 is my longest side because the combinations were 5, 12, 8, 5, 12, 9, 5, 12, 5, 12, 10, and so on. So 12 used to be the longest side every single time. Okay. But now, when I take 5, 12, 13, I cannot say that 12 is the longest side. Now, my combination of longest side, my longest side has changed in the combination of 5, 12, 13, right? So 13 is the longest side, and therefore, I'll be comparing 13 square with 5 square plus 12 square. And they turn out to be equal according to the triplet we know, correct? So this is right angle triangle. Okay. Now let's come to 14. 5, 12, 14, right? So if I want to compare 14 square with 5 square plus 12 square. Now see, I already know that 13 square was equaling this, right? So 14 square will definitely exceed it. 15 square will be even bigger and 16 square will be even bigger, right? So these three cases will definitely give me an obtuse angle triangle only, right? So finally, how many obtuse angle triangles am I having? 1, 2, 3, 4, 5, 6. 6 is the answer. Okay, some people have questioned why didn't we take 5, 6, etc. So actually that was the starting point, if you remember, right? We started with the range of the third side, right? What was the property? A plus B greater than C greater than A minus B. So based on that property, I can find out the range for the third side. If two of the sides are given as 5 and 12, I can say that my third side has to be, lying between 5 plus 12 and 5 minus 12. 12 minus 5. So that is why the range of C was between 7 and 17. Now, if I know that I'm supposed to take the values between 7 and 17, how can I take 6 or 7, right? I should obviously start with 8 and that will end at 16. No, so we are looking for obtuse angle triangle, correct? 1, 2, 3 are obtuse. This is acute. This is acute. This one is right. This is obtuse. So obtuse angle triangles are 6 in total. They are not 7. They are 6. Okay, this is the next point, similarity and congruence of triangle. First of all, what is a similarity and what is a congruence, right? So I can say that similarity is where you have same shape. When we say shape, we indirectly mean angles. And size could be anything, right? Either same or different size. This is what you call similarity in a layman's language. So if you have two triangles, and if it is given that this angle is 50, this angle is 50, this is 30, this is 30, right? Can we say that the triangles are similar? Yes, because they will have same shape, in bracket, same angles. You can see that 50 and 50 are equal. They are called respective angles, right? So respective angles are equal, 50, 50. The other pair of respective angles, 30, 30, that is also same. And therefore, the third pair of respective angle will by default be equal because the remaining angle here has to be 100. The remaining angle here has to be 100 as well. So you have all the respective angles are equal, and therefore you are satisfying this condition, which is the shapes are same, right? Now sizes could be any, it could be same or different, does not matter, right? It could be same or it could be different also, but this establishes the similarity already, correct? Now, suppose this is 2, this is 4, this is 5, this is 10, and this is 6, this is 12. So we can say that we have a similarity of triangle, which is in the ratio of 1 is to 2. This is what you call 1 is to 2 similarity, because each respective side, like this is ABC, suppose, this is PQR, okay? So your AB by PQ is a ratio of 2 by 4, which is 1 by 2. BC by QR is 5 by 10, which is 1 by 2. And AC by PR is also 6 by 12, which is 1 by 2, right? So this is what you call 1 is to 2 similarity. Okay, and 1 is to 2 is what? Ratio of sides. Now what is congruence on the other hand? Congruence is obviously same shape, same size. So over here, you will have 50, 30, 100. And this will also be the same thing, which is 50, 30, 100. Okay. This is 2, 5, 6. This is also 2, 5, 6. So you are saying that you are seeing that not only the shapes are equal, but the sizes are also equal. And that is what we call a congruence. Okay. Now, with the help of this, obviously, we will be able to see that every congruence is always a similarity, isn't it? So for this congruence, we can say that obviously this is a similarity with the ratio of 1 is to 1, and that is true. So every congruence is a similarity with a ratio 1 is to 1. Every similarity may or may not be a congruence, right? Yes, Aditya, I think I have answered this already. And yes, ratio of side, you have to take the ratio of the respective sides. They should be equal for similar triangle, right? So this is 2 by 4. This is how we take the ratio. 5 by 10 and 6 by 12, correct? You can see that all these ratios are 1 by 2. When you simplify that, all of them are 1 by 2. So this is where your ratio of side is 1 by 2, right? Now, there are different ways of proving similarity and congruence, right? So these are the theorems which we'll be using in order to prove similarities or congruence, right? Whenever we prove congruence, we always show that the sides are equal and the angles are also equal, right? Whereas in case of similarity, for angles, we will show that they are equal, but similarity, we will not be showing that the sides are equal. Sides will only have the equal ratio. Like over here, will I say that these two sides are equal? No, but they are in equal ratio, correct? Now, whenever you have similar triangles, please keep it in mind that for two similar triangles, your ratio of sides will be same as ratio of perimeter. Okay, the same information is written already. Ratio of side will be equal to ratio of perimeter. The same holds true for ratio of heights and medians also. Now, what is this height? What is this median? We'll discuss in the upcoming section. Okay. And that is equal to the square root of the ratio of the area. So how are you going to remember this? Suppose if I tell you that there are two triangles having a similarity ratio of sides as let's say 1:3, then the ratio of area should be the square of the ratio of sides, which is 1:9, right? So from side to area, you are always taking the square. For area to side, you are taking the square root. Okay. So if I tell you that two triangles are similar and they have sides ratio as 5:3, you can immediately say that the area ratio between them has to be 25:9. Okay. If I tell you that two triangles are similar and the area ratio between them is 144:81, you can say that the side ratio has to be 12:9, or maybe further simplifying 4:3. Correct. No congruence can have 1:2 ratio. Congruence means equal side. Okay. So if you have 1:2 ratio, if this side is 1 and this side is 2, are you going to say that the sides are equal? No, right? So congruence cannot have any other ratio apart from 1:1. When you say 1:1, it's equality, and equality is congruence. If second triangle is double, triple, then it is not a congruence. It is always a similarity. I mean, it may be a similarity. Now, over here, we are going to use a certain theorems of similarity and congruence, and we are going to check whether we have any relation between the triangles or not. Okay. So this is the data that is given to me. There are two triangles, PQR, XYZ. Okay. So P is 125. This angle is 125. Q is 17 degree. And we have Y equal to 125. Z equal to 17. What can we say about these two triangles? Are they similar? Are they congruent? Or are they unrelated? Looking at the angles, see 125, 125. Can I say one pair of respective angle is equal? Which one? Please write it. P and Y are equal, right? Second angle is Q here, and second angle, which is 17, is Z here. Now, can we say that the third angle by default will be equal? I mean, whatever the measure it is, but it is an equal measure for both the triangles, and therefore R will be equal to X. So this is a similarity because I'm able to show that the angles are equal. Now, angles equal means what? Shapes are equal, isn't it? So I'm only having the shapes which are equal. I have no information about the size. So please don't conclude that it's a congruence. It's a similarity. This is the symbol for similarity. Okay. Next point here. Length of PQ is 15. And on the other hand, we have YZ equal to 15. So can we see that one pair has equal sides? I mean, one of the side have equal measures. 21 is PR, and this is also 21 XY. QR is 24 and this XZ is 24. So here I'm having equal sizes and therefore it is a congruence, right? And you can also say it's a 1:1 ratio. And whenever you have 1:1 ratio, it's always a congruence, correct? How do we write the congruence here? Should we write any random order PQR XYZ? No, please don't do that. You have to write your sides, you have to write your angles in a proper order. Okay, so we start with this 15 side. Okay, what is the angle opposite to that 15 side? R. So I should write R first. Same here. Start with this 15 side. What is the angle opposite to that? X. Next one is 21. What is the angle opposite to that? Q. 21, angle opposite to that is Z. And then the third one, RQP, XZY. This has to be the right order in the congruence. Maintaining the order is very, very important here. Now, the theorem that we used over here is side, 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 because we showed that one pair of side, second pair of side, and the third pair of side are equal. So this is also known as SSS theorem for similar congruence. Next one, P is 65, Q is 45, PQ is 12, and over here we have X equal to 65, Y equal to 45, XY is 12. Now, this is where we have two of the angles equal. Look at this, 65, 65, right? 45, 45. So we can obviously conclude that the third pair of angle will also be equal. So it is undoubtedly, it is already a similarity, right? But can this be a congruence also? So you have to compare the respective sides. So the side which is lying between the angles of 45 and 65 is 12 here. And the same side which is lying between 45 and 65 is 12 here, right? So sides have 1:1 ratio, which means the sides are equal. And therefore, if you have a 1:1 ratio, it's called a congruence, right? Now, what theorem we have used here? We have used angle. See, this 45 and this 45 is equal. So it is called A. Then there is a side, which is called S, which is equal. And then there is an angle, which is equal also. So according to ASA rule, this is a congruence. Now, when we say ASA, please remember that it has to be the same order, which is angle, side, angle, which means the side should always be included between the angles. Then we have 87 degree, which is the measure of Q. 87 degree, which is the measure of Z. Length of PQ is 12. XZ is 12. Then we have QR, which is 8. And then we have YZ equal to 18. Okay, is this a similarity or is this a congruence or they are not related? So at the first glance, it might look like it is a congruence because you will be able to see that this is 12, this is 12, right? So you might be able to generalize, you might end up generalizing that the sides are equal and the ratio is 1:1, right? Had the ratio been 1:1, then these two should also be equal. No, why are they different? So this is giving me a hint that because these are not equal, right, it cannot be a congruence, right? So can this be a similarity where the ratio between the sides are equal? So obviously I'll not be taking the ratio of 12 and 12 and compare with 8 and 18. Those ratios are definitely different, but can I change the order and do something like, let me take 8 upon 12, okay? So how much is 8 upon 12? 2/3. Then there is this angle, right? So this is the ratio of side. Then there is this angle and this angle, which is equal. And then again, I have a ratio of side, which is 12 by 18. This is 2 by 3. So ratio of sides are equal and the angle between them is also equal. So this is known as SAS similarity, right? Now we might be saying that SAS similarity, how is it different from an SAS congruence? Okay, just in case if you have this question, then in SAS similarity, these ratios are equal. I'm not saying that the sides are equal. The ratios are equal, as you can see, 2 by 3, 2 by 3, right? If you have an SAS congruence, then the sides themselves will be equal. So this is the difference. At one place, we are having the ratios equal. At the other place, we are having the sides themselves, which are equal. Yeah, it is not congruent because in congruent, you need to have all the respective sides are equal. Okay, so this is 12, this is 12. It might appear as if it is congruent, but later on, when you compare these two, they are not equal. So obviously congruence is not there. Next question. In triangle PQR, point S lies on side PQ such that PSQ, okay, this is triangle PQR. S lies on PQ. This is S lying on PQ such that PSQ are in that order. Okay, fine. Measure of SRQ. SRQ. This is this SRQ angle, right? That is equal to QPR. QPR. These two angles are equal. Please take a note of this. SRQ, QPR are equal angles. Okay. Further, it is given to me that length of PQ is 12. This is 12. And length of QR is 8. Okay. So when you have these kind of situation, you might think of applying a lot of things, right? But please remember, if you have one pair of angles equal and one pair of side given, highly likely scenario is a similarity through SAS. Not even SAS, it has to be an AA similarity. This can be a highly likely scenario. What is AA similarity? We're going to choose two triangles between whom the angles are equal. Two respective pairs of angles are equal. This is what you call an AA similarity. If this is equal to this and this is equal to this is called AA similarity. But never try to find the AA similarity between the two smaller triangles that are created. You'll not get one, right? You don't try to find out the similarity between these two triangles. Always take one of the smaller triangle and the bigger triangle. Okay, this is how we should think of this problem. Always take one of the smaller triangle and the bigger triangle, right? So what I'm going to do here is, obviously I'm taking the bigger triangle, which is PQR, correct? Along with that, I will be taking this smaller triangle. Okay, I didn't choose SPR for a reason, because for SPR, I do not know any of the side. Do I know SP? No. Do I know PR? No. Do I know SR? No. Okay. Whereas for the second triangle, second smaller triangle, at least I know one of the side. Okay. I don't know SQ. I know QR, and that is the reason I picked this one. Okay. So SQR. Correct. Now, I know that in PQR, the angle P that you are having, let's call it X. Okay. Should be same as angle R here, which is X. Now, you need to have the same angles in the same order. Correct. So over here, if P is written first, over here, I would like to write R first. So I'm changing R to this position. Correct. So this tells me that one pair of angles is equal and that is set in the right order. After that, this angle Q, can we say that this Q and Q must be same? Let us check in the diagram. Don't directly conclude it. In PQR, this is the measure of Q I'm taking, right? In RSQ, I'm taking the same measure of Q. So this is what you call a common angle, right? This is a common angle. And let me just, arrange the order of it. This is the common angle, right? I have already proven an AA similarity. Two pairs of respective angles are equal, my triangles are similar, right? So now I'm going to write the similarity ratio. How do I write the similarity ratio? First two letters, okay, which is PQ divided by RQ is equal to next two letters, QR divided by QS. This is equal to PR, first and last, okay, which is PR divided by RS. Now I can simply substitute what all values do I need. What is PQ? PQ is 12. RQ, 8. QR, obviously 8. QS, see QS is what we require. And we will get QS by comparing the first two ratios, isn't it? So 12 into QS is equal to 8 into 8, 64. And therefore QS is 64 by 12. You can cancel out 4 and write it as 16 by 3. No, I think you should avoid PSR. I've explained the reason why PSR should be avoided, because for PSR, I do not have value of any of the side. I don't know SP, I don't know PR, I don't know SR, right? So there's no point taking PSR. You have to write the ratio of the side in the same order. So first two letters, first of all, you have to arrange the angles in the right order. Correct. Sanidhya. So P and R are equal angles. They both are equal to X. Q and Q are equal angles because it's a common angle, right? So after arranging my angles in the same order, what I'm going to do is first two letters upon first two letters, next two letters upon next two letters, first and third, I was similarity proven. So similarity, I think we have taken the main triangle, which is PQR. Then we have taken the other smaller triangle, QSR, and we tried to show that angles are equal. Correct. One of the angle is already equal. So obviously we are going to use that. The angle which is given as equal, we are going to use that. And the second angle we are going to use is the common angle. So it was given to you that P and R are equal. So we have used that information. And Q turns out to be a common angle. So when that is also equal, and if you put the things in the right order, then according to AA, this is a similarity. Okay, now we are going to learn 30, 60, 90 theorem. Not exactly a theorem, but you can say it's a property. 30, 60, 90 and 45, 45, 90 property, right? First, I'm going to take up 30, 60, 90. So 30, 60, 90 is what, first of all? It is the measure of angles, right? So in one triangle, you will have one of the angles, which is 30 degree. The other one is 60 degree. And the third angle is 90. Whenever you get this kind of 30, 60, 90 triangle, you can say that the ratio of sides opposite to 30, 60, and 90 is going to be 1 root 3, 2. So this 1 is the measure of the side which is opposite to 30 degree angle. So this is 30-degree angle. This has to be 1. Side opposite to 30-degree angle is 1. Side opposite to 60-degree angle is root 3. 60-degree angle, the side opposite to that is root 3. Side opposite to 90-degree angle is 2. This is 90 degree. Side opposite to that is going to be 2. Now the measures can change, but the ratio will still remain the same. So instead of 1 root 3, 2, if you multiply everything by 5, this becomes 5, 5 root 3, 10, which are still in the same ratio, right? So how are we going to remember this information? I will say that you remember two relation. Okay. One is 30 to 60. You are multiplying by root 3. Whenever you are moving from a side opposite to 30 to a side opposite to 90, you should always multiply by root 3. 30 and 60, right? 30 to 60, you multiply by root 3. If you are moving from a side opposite to 30 to a side opposite to 90, you multiply by 2. These are the two rules you are going to remember. 30 to 60, multiply by root 3. 30 to 90, multiply by 2. Now, of course, if you are going in the opposite direction, instead of multiplying, you have to divide, right? That is very obvious and very commonsensical. Let's get a small drill done on this. If I'm giving you 30, 60, 90, these are the angles, okay? And side opposite to 30-degree angle, if I'm telling you that it is, suppose 5. Side opposite to 60-degree angle, you simply need to multiply by root 3 and say that this has to be 5 root 3. Side opposite to 90-degree angle, you need to multiply by 2 and you can say that this is 5 into 2, that is 10. Easy. Let's do another one. If I tell you that side opposite to 90 is 8, how do you get these two, right? From 90, I think you should get to 30 first, right? So I know that from 30 to 90, I was multiplying by 2. And therefore, from 90 to 30, what I need to do is I need to divide by 2, correct? So if this is 8, this needs to be divided by 2, which is 4. If this is 4, can I go from 30 to 60 saying that it has to be root 3 times? Okay. Third example. If I tell you that side opposite to 60 is, let's say, 7, right? Find out the other two. So side opposite to 60 is 7. Side opposite to 30 should be divided by root 3, right? Never go from 60 to 90. Never try to relate 60 and 90. You will need another ratio, right? Third number, which we do not like, right? So keep the things simple. 30 to 60, you already know, multiply by root 3. 60 to 30, divide by root 3, which means this has to be 7 upon root 3. If 30 degree, side opposite to 30 degrees, 7 upon root 3, side opposite to 90 should be how much? Twice of it, which is 14 upon root 3. I hope this is clear. Okay. What about 45, 45, 90? Very similar to 30, 60, 90, just the ratio is different. 45, 45, 90. The ratio of side has to be 1 is to 1 is to root 2, right? So if I tell you that side opposite to 45 degree is suppose 3, then side opposite to another 45 degree is also 3, and side opposite to 90 degree should be 3 root 2, correct? One more example. If I tell you that side opposite to 90 degree is 10, side opposite to 45. Now see, when you are going from 45 to 45, you are keeping it as it is. 45 to 90, you are multiplying by root 2. So 45 to 90, if you multiply by root 2, which means 90 to 45, you have to divide by root 2, correct? So this one is 10. If you want to go to 45, you have to divide by root 2. 10 upon root 2, 10 upon root 2, which can later be simplified as pi root 2, right? Which will do, right? But this is how you can simply divide this side opposite to 90 by root 2 and can get side opposite to 45, right? Now this calculation will be very, very important. And of course, you will not get a direct sum on this. but this is something which will be used in most of the sums, majority of the sums. Okay, let's practice this again in this example. In triangle VWX, V is 30. Let's try to draw a rough diagram as well. V is 30. W is 60. This is X. Okay. VW is equal to 10. This is 10. Vx and Wx is to be found out. So we know that side opposite to 90 is 10, isn't it? Side opposite to 90 is 10. So how do you get from 90? How do you go from 90 to 30? From 90 to 30, you have to divide by 2, which means side opposite to 30 should be half of 10, which is 5. Once you get side opposite to 30, you can find out side opposite to 60. For that, you need to multiply by root 3. So if this is 5, this has to be 5 root 3. That's it. Okay. The next agenda is basic proportionality theorem and a midpoint theorem, right? So what is the basic proportionality theorem? ABC is a triangle. Suppose M is a point here, which is not necessarily a midpoint, okay? And N is also a point here such that MN is parallel to BC. MN is parallel to BC. If this is given to you, then you can say that the ratio of AM upon BM, right? The two parts in which side AB gets divided. The two parts in which side AB gets divided is AM upon AB will be same as the two parts in which side AC gets divided, which is AN upon CN. This is what we call basic proportionality theorem. What is a midpoint theorem? Midpoint theorem is, I can say, a special case of basic proportionality theorem where you are just joining the midpoints. Triangle ABC. M is the midpoint of AB. M is strictly a midpoint, and therefore these two parts are equal. N is a midpoint of BC, and P is a midpoint of AC. So all of these are midpoints only, correct? If you join these midpoints, suppose, let me join MP, right? If I join MP, which is nothing but midpoint to midpoint, right? So this MP, okay, yeah, I just noticed that I've written AB mistakenly over here. I'll correct it. BM, it has to be. I hope this is fine now. Yes. Yes. So let me give you both the forms. You can do whatever you are comfortable with. So AM, so if you take parts, you have to take parts on both the side, right? AM is a part, BM is a part, right? So these are the parts that we are equating. AN on the other side, CN on the other side. If you want to equate, let's say, the whole side, AM upon AB, you just take the whole side on the other side as well. Even this is also true. No problem with that, right? No point remembering both the things. You can, keep in mind any one of them. That should be absolutely fine. Okay, coming back to the midpoint theorem. If I'm joining the midpoints of AB and AC, M is the midpoint of AB, P is the midpoint of AC. If I'm joining MP, then MP will be half of BC and MP will be parallel to BC. MP is parallel to BC. This is midpoint theorem. Okay. So if your BC is, let's say, suppose 10, MP has to be 5. As simple as this. Correct. Now, when you repeat this midpoint theorem 3 times in this triangle, That is, you are joining MP, then you are joining MN also, and you are joining PN also. So in that case, what you will end up creating is an inner triangle, which is formed by joining the midpoints of the outer triangle, right? This is what I can call an inner triangle. The inner triangle is formed by joining the midpoints of the outer triangle, right? Whenever this happens, you can say that the four resultant triangles are having the same area. Can you see four resultant triangles? This is first one, AMP, second one, MBN, third one, MPN, and the fourth one, NPC. All these four triangles are going to have equal area, and therefore, if you just want to take the ratio of your inner versus outer in terms of area, then it is going to be x upon 4x. So it is 1:4 in terms of area. Let's look at one question on this. In a triangle ABC, AB is 12, AC is 9. AB, AC. AB is 12, AC is 9. BC is 13. D and E are points on AB and AC, respectively. So D is here, E is here, such that DE is parallel to BC. Now they've made D parallel to BC, which means I can now use a basic proportionality theorem, right? Length of AE is 6. This is 6. Find out length of BD. Now, you know that this is 6, okay, and this is 9. You can say that this is 3. So 6 upon 3 is AD upon DB. So how much is that? 2 upon 1. Can we simply divide the total value, which is 12, in the ratio of 2:1? So when you divide 12 in the ratio of 2:1, this is going to be 8, and this is going to be 4. Now you can answer whatever is required. If you require BD, that has to be 4. Yes, outer itself is the total. So when we say outer triangle, correct, what is outer triangle? Outer triangle is ABC, right? And what is ABC? ABC is 4x. Yes, N was the midpoint here. M is the midpoint, N is the midpoint, P is the midpoint also. In the following figure, now these are very standard questions, okay? And these kind of questions have been asked in CAT multiple times, and they are easy also. In the following figure, PQ is parallel to BC. This is PQ, this is BC, PQ parallel to BC. Twice the length of AB is equal to thrice the length of AP. Let me simply take the ratio of AB upon AP. How much is that? 3 upon 2. So AB upon AP. This has a ratio of 3:2, correct? You can say this is 3K. So this will be 2K. And therefore, if you want the lower part, that will be 1K. What is required? Area of APQ. Now, when it comes to area, you need to get into the similarity between the smaller triangle and the larger triangle, right? So how are you going to take the similarity? So this is your APQ. This is your ABC. Correct? AP is 2K, as you can see, and AB is 3K. So these two respective sides have a ratio of 2:3, and that 2:3 becomes the similarity ratio also, right? How do I get the similarity between them, by the way? So I know that angle P and angle B are equal. What is the reason for that? Remember, PQ is parallel to BC. That is given, right? So these two are parallel. Now, what kind of angles are these? These are corresponding angles, and corresponding angles on parallel line are equal. That's the reason P and B are equal. Okay, so P and B are equal. And then, due to the same reason, I can say Q and C are also equal. Correct. So now, these two triangles are similar triangles. And therefore, what is the ratio of the sides? 2:3. If the ratio of the sides is 2:3, I can say that the ratio of areas has to be the square. We have learned this property earlier, right? So it has to be 4:9. Now, APQ is 40, correct? This is APQ. This triangle has an area of 40. This is the ratio. This is the actual area, correct? So actual area is 40, which means I can compare like this. 4 parts are equal to 40. If 4 parts are 40, how much is 9 parts? Obviously 90, correct? Now, look, what happens is this is 90 and this is 40, right? So how much is the lower part? If I tell you that the whole is 90, the upper part is 40, the lower part has to be how much? 50, isn't it? Very simple question. The ratio of area between two similar triangle is equal to square of the ratio of side. If the triangles are similar, okay, in that case, the ratio of area is equal to square of the ratio of side. So if your ratio of side happens to be 2:3, the ratio of area should be 4:9, correct? How did we distribute 3K and 2K? So because this ratio of AB upon AP, if I shift AP on the left and 2 on the right, what I'm getting is AB upon AP is 3/2. I just need to go to the diagram and write AB as 3 parts. So 3 parts is 3K and AP as 2 parts, which is going to be 2K, right? And then what I'm going to do is I'm going to separate these two triangles. When I separate these two triangles, I will be able to show that the corresponding angles, the respective angles are equal. If the respective angles are equal, it has to be a similarity. And because the similarity has a ratio of 2:3 in terms of sides, in terms of area, it has to be a square, which is 4:9. If it is 4:9, one of the triangles area is already given, which is the smaller one. If that is 40, right? 4 parts is 40. So you can always equate 9 parts as 90, right? So smaller one is 40, bigger one is 90. The area in between, which is the quadrilateral, has to be 50. No, Rakshit. You will still get the same answer. Now see, Janvi, these two triangles can never be congruent, no? This triangle and this triangle, how can they be congruent? Because one is a smaller one, the other is a larger one, correct? So there is no point they should be congruent. It has to be a similarity always. How it is 50? So see, this is 90, correct? If you understand that the bigger triangle has an area of 90, smaller one has an area of 40. So 90 minus 40, this has to be 50, no? It is simply a subtraction, nothing else. Next question. In the figure given below, P is a point. First of all, this point is P. this is the point inside the triangle ABC. We can see that this point is located inside the triangle, right? Line segment DE, where is DE? Okay, this is DE, FG, and HI are drawn through point P, parallel to the side AB, BCCA respectively. Okay, so over here you have the pairs of parallel sides. Let me draw parallel sides with the with same color, right? So DE is parallel to AB. I'm going to highlight both of them with the same color. DE is parallel to AB. The next set of parallel sides are FG and BC. FG is parallel to BC. And the third one is HI and CA. This is HI. And that's parallel to CA. Right? You should remember that the sides highlighted with the same marker are parallel sides. Now the areas of the triangle DPG. Where is DPG? This one is DPG. So we'll mark the area over there, which is 9. FPI has an area of 16. And this one is 25, which is EPH. EPH, this is 25, right? So can we take the ratio of area for these three triangles? Let me first tell you that these triangles are similar triangles, right? Which is very obvious because if you look at this angle and this angle, they should be equal. And even this angle should be equal, right? So all three respective angles, that is 1, 2, and 3 angles, all these three are equal, right? Similarly, I can say this angle, and this angle are also equal. You might wonder why are they equal? Because see, the sides are parallel, correct? So whenever you draw a transversal here, these all become corresponding angles, and those corresponding angles will be equal. Hence, this gives us a similarity, right? So I can say that this triangle DPG is similar to IFP, which is similar to PEH. And at the same time, it is also similar to the largest triangle, which is ABC. All these are similar, right? I can say that even for ABC also, so this angle will be same. Okay, F, P, E, B. All these 4 angles are same, correct? Similarly, this angle P over here, which is IPF, then DGP, PHE, and this angle, which is ACB, they are equal, right? So due to that, it has a similarity with the main triangle also, which is ABC, right? Now, what is the ratio of area? The ratio of area is 9, 16, 25, which are actual areas also. 9, 16, 25. If the ratio of area is 9, 16, 25, can we say that the ratio of side between them has to be the square root? Remember, side to area is a square, area to side is a square root. So this has to be 3, 4, 5, correct? So DPG has a side of 3. If I take this as 3K, then IFP, the side has to be 4. This has to be 4K. And PEH, the side has to be 5, which can be taken as 5K. So what I've entered here is, this is 3K, this is 4K, this is 5K. Sides are in the ratio of 3, 4, 5. I should not take 3, 4, 5 directly. So I'm taking 3K, 4K, 5K, right? Now, if this is 3K, this has to be 3K because the lines are parallel. So parallel lines will have equal distance, correct? And you can also look at the same thing in a slightly different way, that this is a parallelogram, so the opposite sides will be equal. So if this is 3K, this will be 3K, correct? Also, if this is 5K, this has to be 5K. Now this helps me know the side of the largest triangle, which is 3K plus 4K plus 5K, that is 12K. So now I can say that this has a ratio of side as 3, 4, 5, 12. Correct. If the ratio of side is 3, 4, 5, 12, then the ratio of area will be 3 square 9, 4 square 16, 5 square 25, and 12 square 144. And these are the actual numbers. So this will also be an actual number. It's basically one multiple, you can say, right? So answer is 144. Now we're going to discuss median, altitude, perpendicular bisector, and angle bisector, right? So first of all, what is a median? Median should satisfy two things. It should be drawn from the vertex, and it should be passing through the midpoint of the opposite side. So this is vertex A, B, C. If you draw a line which passes through A and passes through midpoint of BC, this line AM is known as a median, right? Now, please remember that your median should have only these two qualifications, which means it should pass through vertex, it should pass through the midpoint of the opposite side. It should not have any other quality, right? Some people mistakenly assume that because it's a median, it has to divide the angle in two parts. No, right? You should not assume that the median will make two equal angles here. No, it is not correct. The median will not make two equal angles either at the foot of the, either at the point M also, right? So please make sure that you are not taking any unnecessary extra assumption over here, right? What is an altitude then? Altitude is something which is passing through vertex and perpendicular to the opposite side. A, B, C. Drop a perpendicular here. This is what you can say an altitude is, right? Altitude will again have two qualification, which is passing through vertex and perpendicular to the opposite side. It will not necessarily pass through the midpoint of the opposite side. It will not divide this angle equally, right? Again, please avoid taking the additional assumptions. What is perpendicular bisector? So as the name suggests, what is the name? Perpendicular bisector, right? Which means it should be perpendicular to the side of the triangle and it should also bisect the side of the triangle. What is the meaning of bisect? Make equal parts, right? And therefore, if I want to draw perpendicular bisector for, let's say, side BC, in that case, I will look at the midpoint of BC and draw a perpendicular from that point. This line becomes perpendicular bisector. Check this. It is perpendicular, making 90 degree, and it is bisecting BC, which means, in other words, you can say passing through the midpoint of BC. Correct. So I hope you are able to distinguish between these three, right? And obviously, this will not pass through, this may not pass through the vertex, correct? If you draw, now we are first concentrating on these three things only. I'll cover angle bisector part later, okay? So if we just consider on median, altitude, and perpendicular bisector, first we have spoken about their definition, correct? Now, in every triangle, you will be able to draw three medians, three altitudes, three perpendicular bisectors. Okay, so they will give you some center over here, right? What are the names of these centers? Point of intersection of median is known as a centroid. So this point here is a centroid. Point of intersection of altitudes is known as orthocenter. And point of intersection of perpendicular bisector will be known as a circumcenter. So make sure that you know the names of these centers also. These centers are nothing but the point of intersections of medians, altitudes, and perpendicular bisectors respectively, right? Now, when it comes to properties of median, I'm talking about property of median. So median divides the area of triangle into two equal parts. Median divides area in two equal parts. So suppose there is a triangle here. If I tell you that the area of this triangle is 50, if you drop a median, this 50 gets divided into two equal areas of 25, 25. Correct? That's the property of median. Property of centroid. Centroid divides the area of triangle in 6 equal parts. Very, very important property. So when you have this centroid, right, it will obviously be a point of intersection of three medians. So when you draw three medians, when you put a centroid in the triangle, you will be able to see that your triangle has been divided into 6 areas which are equal. Okay. This is true for any triangle. Yes, altitude and height are the same. No, I didn't say that the median does not divide the triangle in equal parts. I said that median will not make a right angle at the bottom. It will not have equal angle at point A, right? But yeah, this is the property of median, which is followed, right? So it makes two equal parts of the area. It does not divide the angle equally. Yes, it is already written over here. So if you refer the notes which are there on your slide, okay, median will pass through vertex, definitely correct. Yeah. So coming back, median divides the area of triangle in two equal parts and centroid divides the area of triangle in 6 equal parts. One more property of centroid, that is centroid divides median in 2:1 ratio from vertex. So suppose your median is AM and this centroid is pointed G. If I tell you that AM is 12 units long, then this AM gets divided in the ratio of 2:1 from the vertex, which means this part has to be two parts. This part has to be one part. So what you can actually do is you can take it as 2K and 1K, right? So AG is 2K and GM is 1K. This is how it gets divided in 2:1. And AG plus GM is equal to AM. So you can say that this 2K plus 1K equal to 12. Effectively, 3K is 12 and therefore K is 4. So the 2K part was 8 and this 1K part will be 4. Not necessarily for you to follow the K method always, right? It's very easy to see that 12 gets divided in the ratio of 2:1 as 8 and 4. This is 2:1, right? You can do it directly also. Yeah, so these were the properties of median and property of centroid. Coming to altitude, right? We have already discussed that the point of intersection of altitude is known as this orthocenter, right? Now, please write down the angle at the orthocenter here, right? I'm going to write the orthocenter property over here. Angle at the orthocenter is equal to 180 minus the opposite angle. I repeat, angle at the ortho center is 180 minus the opposite angle. So what do we mean by that? Suppose, let's say ortho center is H here. Okay. So you have this angle BHC. I hope you're able to see that. BHC. That angle is known as angle at the ortho center, right? So I can say that BHC is 180 minus, what is the opposite angle? This is the opposite angle, right? So when you talk about BHC, the opposite angle has to be A. This is how one can find out the angle at the ortho center. Okay. About perpendicular bisector, the property here is that the point of intersection of that is circumcenter, and circumcenter can become the center of circumscribed circle, right? It can become the center of the circumscribed circle, which means taking this point as a center, let's say this point is P. So taking P as a center, you can draw a circle which can circumscribe the entire triangle. What is the meaning of circumscribing? Covering from outside. Okay. So you draw a circle from P as a center, which will cover the triangle from outside. This is what you call circumscribed circle, right? And for this circle, your PA or PB or PC are known as a circumradius. Circumradius is known as a capital R. So PA equal to PB equal to PC is known as a circumradius, which is capital R. And what is angle at the circumcenter? BPC is equal to twice of opposite angle, or you can say twice of A. This is the property of perpendicular bisector and circumcenter. BPC is twice of A, that is angle at the circumcenter. Now I'm going to talk about Apollonius theorem. And this is done, this is done, this is done. Perpendicular bisector, circumcenter, circumscribed circle, angle at the circumcenter. Yeah, we are only left with the Apollonius theorem. So let's change the slide and discuss it somewhere here. Okay, I think people have taken note of this, right? So I'm going to erase this. Apollonius theorem. Please write down. You should be using it for medians only, right? Never use it for altitude, perpendicular bisector, or angle bisector. What is the theorem? It is giving you the measure of the median. AM is the median here. Okay. So the theorem says that AB square plus AC square is equal to twice of AM square twice of BM square. This is Apollonius theorem, right? AB is definitely the length of side. AC is also the length of side. BM is half of the length of the side. AM is your median. So if three of them are given, you can find out the length of the median. Simple. I'll now be moving to the previous slide. Let us now discuss the last point over here, which is angle bisector and the properties related to that. Okay, I hope you have taken note of all the properties that are written on this slide. Yes, that's correct. Over here, instead of BM, you can also use a CM because BM and CM, they are equal, correct? Fine. So on this slide, I'm going to discuss the angle bisector properties. This is angle bisector. The only qualification of an angle bisector is that it will bisect the angle. Okay. It will not pass through the midpoint. It will not be perpendicular. It will not divide your area equally. Okay. It is just going to divide this angle equally. That's all. Right. Now, if you draw angle bisectors in a triangle, right, then the ratio of these two, suppose AD is your angle bisector. Okay, so you have a ratio of two parts of sides on the left hand side. That ratio is equal to these two parts which are on the right side of the angle bisector. Correct? So how do we write this ratio? AB upon BD is equal to AC upon CD. This ratio itself is known as angle bisector theorem. This is known as angle bisector theorem. Moving on with the angle bisector, just like we can draw three medians, three altitudes, three what do you say, perpendicular bisectors, right? Similarly, you will be able to draw three angle bisectors within a triangle, right? So if I'm drawing three angle bisectors, this one for A, another one for B, and one for C. These three will also intersect at a common point, and that point is known as in center. In center is given by I, capital I, right? As far as properties of in center are concerned, it will be the center of the inscribed circle. You must have heard of inscribed circle, right? It is the circle which is drawn inside the triangle. Quite opposite to the circumscribed circle which is drawn outside the triangle. This one is drawn inside the triangle, right? And because it is drawn inside the triangle, it is going to touch all the sides. Correct. It is called inscribed circle. And the radius of this inscribed circle will be small r. Circumscribed circle, you have a capital R as a radius because it's a bigger circle, so capital R. This is a smaller circle, so small r, right? And angle at the incenter is going to be 90 plus half the opposite angle. Okay, which means BIC is 90 plus half A. In general, this is half of the opposite angle, I should say. Okay, so please make sure that you have taken note of these properties. In the adjoining figure, now let's discuss question based on the same. In the adjoining figure, PM and CM are angle bisectors. So you can see in this diagram that PM is the angle bisector. So these two angles are equal. CM also is an angle bisector. So eventually M becomes your incenter. Please remember, point of intersection of angle bisectors should be incenter. Now BAC is 30. 70. So this angle is given as 70. I should find out the measure of BMC, which is this one. What should I do? Straight away, use this formula. BMC is 90 plus half the opposite angle. Opposite angle is 70 in this case. Okay, so 90 plus half of 70, which is 35. 90 plus 35. The answer is 125. Opposite angle mean the same thing here, right? So this is the angle you're talking about. The opposite angle is over here. I'm going to keep this slide on for another 10 to 15 seconds. right? And then I'll go to the previous slide. There are some requests from the students for the previous slide. So please make sure that on this slide you have completed taking all the notes. Yes, whatever you are able to see here itself is the angle bisector theorem. Okay, Pooja. AB upon BD, the ratio of two sides written in blue color is same as ratio of two sides written in green color. Okay, external. External is also very similar. You first need an exterior angle. This is the external bisector. And this is ABC. This has to be point D. Ratio remains the same. AB upon BD equal to AC upon CD. No change with the ratio part. This is the external angle bisector. So Preksha, we have solved BMC only, no? See, in general, I'm saying that this is I. But for a specific question, this I is replaced by M. It is very much obvious that this BIC that we have written here will also become BMC, correct? I hope that is something that we can figure out. So for this question, it is BMC, okay? Yeah, this is the previous slide. And this one is one slide prior to that. Yes, somebody mentioned 3:4 ratio for Apollonius theorem. So it's not exactly an Apollonius theorem, but it is the derivation of an Apollonius theorem, or you can say a corollary which is based on Apollonius theorem, which goes like this. If you want to write down, you can please. 3 times the sum of squares of side. This might be a property which can be rarely used in some one-off question. 3 times the sum of squares of side is equal to 4 times sum of square of median. This is square. This is also square. This is a derivation which can be done based on Apollonius theorem. Let's look at the next question. In the figure, AD, BE, CF are the altitudes. The moment you read that they are altitudes, this point becomes orthocenter, isn't it? They are meeting at point O. ACB is 70. ACB, this is 70. Find out AOB. AOB. This is nothing but angle at orthocenter, which is 180 minus A. 180 180 minus, I should write opposite angle. That is a better usage. So over here, we want this angle, and the opposite angle is this one, which is 70. Answer has to be 110. If you know the property, it's a straightforward question. I think we have displayed this slide 4 times. By now, you should have taken the notes, correct? Let's see the next question. ABC is a triangle, and AD, BE, CF are the medians from the vertices ABC respectively. The area of ABC is 24. The area of the whole triangle is 24. Compute the area of, there are several triangles given here. ABD, AOB, AOF, and so on, right? So first thing we know that, remember the properties now. Median divides the area of triangle in two equal parts, which means if total area is 24, I can say that by drawing a median, this area becomes 12 and the remaining area becomes 12, right? So this is one thing I know. Second thing that I know is centroid divides the area of triangle into six equal parts. So 24, if I divide that into six equal parts, then each of these area is 4. Correct. What else do I know about this scenario? I know that A, B, C, these are nothing but the midpoints only, right? Uh, when you draw the median, you are obviously connecting the vertex with the midpoint of the opposite side. So D is the midpoint. Similarly, F and E are also the midpoint. If I now only connect these midpoints, right? So it looks something like this. Correct. And this is giving me 4 equal triangles in terms of area. We have discussed when midpoint theorem was explained. Correct. So the same area of 24 is now divided into 4 equal parts with the help of this. So each of these area is 6. This is the information I'm already having, right? Now let's try to answer the question. ABD. Where is ABD? A, B, D. So ABD is nothing but this area, right? Which is 4 plus 4 plus 4. So answer is 12. AOB. AOB. So can you see that AOB is this area, which is 4 plus 4. So that is equal to 8. How much is AOF? AOF is this much only, which is 4. AEF. Now AEF, I will not answer from this diagram. I'll answer it from this diagram. How much is AEF? 6. DEF is also 6. AED, AED. Okay. So what we are going to do here is join, right? This is my AED. I know that this area is 4, correct? This area is also 4, right? And when I'm drawing this line over here, what will happen is, see, this area is 6, correct? So can we say that the same area over here is this part, which is 6, right? I'm just showing 6 and 6 as equal area, correct? Total was 4 plus 4, 8. Out of this 8, if 6 is over here, then can we say this 2 is inside, right? And because these are medians only, they will be divided equally. The areas will be divided equally, which means this 6 can be equally split as 3 and 3. And this 2 can be equally split as 1 and 1. Right? So earlier it was 4. Now it has been split into 3 and 1 using this part, which is 6. Correct? Now can we answer AED? AED. So that is going to be 4, 5, and 6. EOF. EOF. Same thing. I think we can split all these 4s and into 3s and 1s. Correct. This is 3 and 1. This is also 3 and 1. So now on the basis of this, I can answer EOF, which is EOF. That is 1 plus 1, 2. And finally, AEOF. AEOF. That is 4 plus 4, 8. This is AEOF. That is 8. So 6 is very obvious. Remember the midpoint theorem and the result related to that. You have ABC, right? You join the midpoint, you join the midpoint, you join the midpoint. Didn't we discuss that all these are equal? Correct. Which means total area is 4x, right? So here it is 24. If you say 24 is 4x, then x is going to be 6, isn't it? So this is 6, this is 6, this is 6, and this is 6. This is how we get all these as 6, right? Remember, whenever you join the midpoint, the entire area gets divided into 4 equal parts. So 24, when you divide in 4 equal parts, it is going to be 6 each, correct? After that, what we did over here is, see, we know that this is 4, 4, 4, 4, 4, and 4, correct? Currently, we know this. If I just erase this 4, and if I try to join this AD, how much is this ACD? We know that it is 6. So over here, this area is 6. This 6 has to be split equally as 3 and 1, 3 and 3, correct? But we also know at the same time that the total was 4. So if this 3 is here, then remaining 1 has to be here, correct? Same way, the total is 4. So if 3 is here, remaining 1 is here. Now this 3-1 splitting can be done everywhere, correct? So this was 4. This is 3 and 1. This is 3 and 1. And similarly, this is 4. This will be 3 and 1. 3 and 1, correct? Properties of right angled triangle. If this side is taken as A, this is B, this is C, and this is H. What is H here? Altitude on hypotenuse. That is equal to AB upon C. A, B, C. This is M, M for median. See, H is the height, M is median. Median on hypotenuse is C by 2. Hypotenuse by 2. This is called in radius. In radius of a right angle triangle is A plus B minus C upon 2. This is called circumradius. Circumradius of a right angle triangle is C by 2. So you will say this is hypotenuse by 2 and this is hypotenuse by 2. Correct. Both are hypotenuse by 2. For altitude on hypotenuse, this is one formula. Correct. There will be another scenario of it, which is something like this. H is required. This time ABC were given to me. Correct. So I could use AB upon C. Suppose ABC are not given, but these two parts are given, X and Y. So C will be equal to X plus Y. That is obvious, but we do not have A and B given. So how do we get H in this case? H is under root of XY. This is alternative formula by which you can find out the altitude on hypotenuse just in case if ABC are not given and only X and Y are given. These are the formulas specifically used for right angle triangles only. Please do not use them anywhere else. I'll keep this slide on for another 20 to 25 seconds. Please finish taking notes. Three sides of the triangle are 8, 15, 17. 8, 15, 17. You should know that whenever you have 8, 15, 17, it must be a right angle triangle. Okay. Calculate the distance of the midpoint of the hypotenuse. This is the midpoint of the hypotenuse from the vertex opposite to the hypotenuse, from the vertex opposite. So if I'm connecting these 2 points, what exactly is this? Is this a median or is this an altitude? By definition, it should be a median because midpoint of the hypotenuse from the opposite vertex. That's nothing but midpoint. That is nothing but median. So median on hypotenuse is c by 2 or hypotenuse by 2, which is 17 upon 2. Answer is 8.5. What is the ratio of circumradius to inradius of an isosceles right angle triangle? You have an isosceles right angle triangle. When it is isosceles, the adjacent sides are equal. Okay. So if you take this as 1, 1, this will be root 2. You can say 45, 45, 90 triangle. Now, some of you might just wonder, how do we assume the measure as 1? Right. I'm assuming 1 because ultimately we do not need answer in terms of absolute value. We need the answer in terms of ratio. Correct. So taking the value is a safe here. If I want to find out some measure, then I cannot start with 1. Okay. Yeah. So we want ratio of circumradius to inradius. Circumradius is capital R, inradius is small r. What was the formula for both of them? This was c by 2 and this was a plus b minus c by 2. Correct. This 2 gets cancelled out. We can put the values for a, b and c. This is root 2. A is 1, b is 1 and c is root 2. 1, 1, root 2. This is going to be root 2 upon 1 plus 1, 2 minus root 2. Okay. I can take root 2 common in the denominator. Root 2 common, this is root 2 minus 1. This is cancelled out. So this is my answer and I can probably rationalize it, which is root 2 plus 1 upon 1. See, we are discussing only the properties. We are far from the reasons of any of the whys. Why is this formula like that? Or why is the answer to median is c by 2? That cannot be explained because if we are getting into derivation, we'll end up stretching this session beyond 3 hours, right? So all those derivations and property you would have done along with the proofs, if at all it is required. That could have been done in the regular class because this is a revision class for triangles 1 and 2. You know that for the regular lecture of triangle, you are getting 2 sessions, which we are going to cover in a single session. On the top of that, we are getting at least 10 CAT questions. So I'll not be in a position to prove anything over here, right? No. C by 2 was for median as well as for, see, I mentioned this, no? This is C by 2 and this is C by 2, correct? So if it's the same formula, please don't be surprised. Area of triangle, it can be half base into height. That is where a side is given and a perpendicular on the side is given. So if you know base and height, you can take half base height as the area of the triangle, right? Then if you have two of the sides given, A and B, angle between those two sides, then you can take area of triangle as half AB sine theta. Heron's formula, if you know three sides A, B, C, then area can be calculated as under root of S, S minus A, S minus B, S minus C. S is nothing but semi-perimeter, which is A plus B plus C upon 2. The next formula for area of triangle is in terms of the circumradius, ABC upon 4R. So what exactly does this mean? Suppose you have a triangle. You have a circumscribing circle. The radius of this particular circumscribed circle is capital R, right? So if you want to give your area in terms of the circumradius, you will be using this ABC by 4R formula. Area of triangle in terms of in radius. So if you want to give your area in terms of this small r, which is in radius, then it is small r into s. These five formula can be applicable to any triangle. If this is what you are asking, it is applicable to any triangle, right? The last one is only for equilateral triangle, that is root 3 by 4a square, where a happens to be the side of an equilateral triangle. Semi-perimeter is not divided by 3, it will be divided by 2 only. S is a plus b plus c divided by 2. The fifth formula is area of triangle is in radius into semi-perimeter, r into s. Same thing, r into s. Yeah, these five formula are applicable to any of the triangle, and the last one is applicable for only equilateral. And as long as these are concerned, so it's already mentioned here that they are valid only for a right angle triangle. Okay. Along with this, you should know two more things for an equilateral triangle. I'll just clear the screen here. For an equilateral triangle, this median and height will be equal, first of all. Correct. Because it's an equilateral triangle. So median and height both will be same. And that is equal to root 3a by 2. So this is a, this is a, this is a, this is a root 3a by 2. And another thing for an equilateral triangle only, the ratio of in radius and circumradius. So small r is to capital R is 1 is to 2. This is the in radius. And this is the circumradius. The ratio is going to be 1 is to 2. Only for equilateral triangle. Find out the area of the triangle ABC if AB equal to 13, AC equal to 13, and median AD equal to 12. So these two sides are equal. A, B, C. This is 13, this is 13. Now, because you have an isosceles triangle, not all the medians and altitudes are equal, but the median which is passing through this vertex will be the altitude. Correct? Because you have isosceles triangle. So one of the median will be same as the altitude, which is passing between the equal sides. So this AD, you can say it is median as well as altitude. The same cannot be said for median passing through B or altitude passing through B. They will not be equal. Same for C also. That will not be equal. It is just one median which is passing through A becomes the altitude also. Okay, AD is 12. So this is 12, right? And it will be perpendicular also. So you can say that it becomes height as well, right? Yeah, that we already discussed. It's an altitude, so it is perpendicular, right? Now see, this is 12, this is 13, right? So once you see 12 and 13, you should be able to figure out that the third side has to be 5, correct? So it's 5, 12, 13 right angle triangle. Can you now find out the area of this right angle triangle? Half into base into height. So half into 5 into 12. How much is that? 30. If this triangle has an area of 30, this one will also have an area of 30, which means the total area is going to be 60. An equilateral triangle has a perimeter of 12. This is an equilateral triangle. 3a is the perimeter, and that is equal to 12, which means a is equal to 4, right? So you can say each side is 4 here. Now find out the altitude and the area. We know that the altitude of the equilateral triangle is root 3a by 2. We have just discussed the formula, right? So it is root 3 into 4 divided by 2, which is 2 root 3. This is the altitude. What about the area? Root 3 by 4, a square, which is root 3 by 4 into 4 square. That is 4 root 3. These are just simple applications of the formula I'm showing you, right? Do not expect these things to, appear in the exam. Find out the ratio of circumradius and inradius in an equilateral triangle. We know that for equilateral triangle, the ratio of inradius and circumradius is 1:2. Here they've asked for circumradius and inradius, so it has to be 2:1 as the ratio, directly from the theory that we have discussed. In the triangle ABC, the medians BP and CQ are perpendicular to each other. This is triangle ABC. Median BP, median CQ, they are perpendicular to each other. Okay, there's a 90-degree over here. Intersect at R. Okay, this point is R. BP is 8. Now this is given as 8. CQ is 12. And R is a centroid, remember. R is centroid. If I know that CQ is 12, centroid divides the median in the ratio of 2:1 from the vertex, right? So 12 you can divide in the ratio of 2:1, that is 8 and 4, right? So the part from the vertex, that is CR, this length is going to be 8, and this RQ is going to be 4. So this is the breakup of your CQ. It is going to be 8 and 4, right? Now, we want to find out the area of the triangle ABC. Just focus all your attention on the triangle that I'm highlighting here. So BPC is the triangle, right? Just focus on that. Can we say that CR is the altitude? Why altitude? Because this is 90 everywhere. You know that it's a right angle between the medians. Okay, they are perpendicular. So CPB, CPB, this is what we have, right? How much is PB? PB is 8. Look at this. This is 8 given. And how much is CR, which is perpendicular as well? CR is 8 as well. Correct. So how much is the area of this triangle? According to the half base height formula, it is going to be 32, right? So the triangle that I've highlighted is 32. The other triangle is also 32. Why? Because median divides the area of triangle into equal parts. So if this triangle is 32 in terms of area, this triangle is also 32, and therefore the total area is 64. From here on, we are starting with past CAT questions. This is the first one. Let T be the triangle formed by the straight line 3x plus 5y minus 45 equal to 0. So this is the line 3x plus 5y minus 45 equal to 0, right? And the coordinate axis. So this is your x-axis, this is your y-axis, right? And this line will cut the axis in these 2 points, right? These we can figure out by taking x equal to 0 and y equal to 0 respectively, right? So when you take x equal to 0, you will get 5y equal to 45, which means y equal to 15, 9, sorry. Y equal to 9. So this point of intersection with y-axis is 0, 9. And similarly, when you put y equal to 0, you will get 3x equal to 45. So x equal to 15. This is your point of intersection with x-axis, right? Let the circumcircle of T, T they have used for a triangle. Okay, so this entire triangle can be called T. This thing is T. AOB is a triangle T. And then it will have a circumcircle. This is the circumcircle of a radius L. Okay, so circumradius is generally capital R, which they have taken as L in this question. Correct. Measured in the same unit as the coordinate axis. The integer closest to L is how much? Basically, you are looking to find out the circumradius. How do you find out the circumradius? We know that it is half the hypotenuse, right? So find out the hypotenuse, take half of it, and that is your answer. How do you find out the hypotenuse? You know that if this is 0, 9 and this is 0, 0, this length has to be 9. If this is 15 and this is 0, this length has to be 15. Can we find out the third side of the hypotenuse? And remember, triplet is not applicable here because 15 is the side making right angle. It is not the hypotenuse, right? So we have to find out the third side, AB, as AB square equal to 9 square plus 15 square. This is 81, this is 225, and that is equal to, in fact, what I can do is, I can make it slightly easy. That is, if you know that this is 9, this is 15, and this is unknown, right? Rather than applying the Pythagoras theorem on 9 and 15, I can take 3 common. Then I will say that, okay, I'm left with 3 here, 5 here. So how much is this, right? So this is easy now. It can be 3 square plus 5 square under root, which is 25 plus 9, 34. So if this is under root 34, the actual side has to be 3 times of it, right? This is what we have done today. 3 times 34 under root. So this is my hypotenuse. And in radius is 3 times 34 under root upon 2. Now root 34 is how much? Approximately 6. We know that root 36 is 6. So root 34 is approximately 6. And that is what they have asked for, right? The closest value of L. The integer closest to the value of L. So approximate answer is what we are looking for. So take this as 6 approximately. divide by 2. This has to be approximately 9. Next question. Medians BD and CE of a triangle ABC intersect at point O. If area of triangle ABC is 108 square centimeter, the area of triangle EOD is how much? A, B, C. BD and CE are the medians. Okay. This is BD. This is CE. These are the medians and they intersect at O. So O becomes your centroid, right? Now, if two of the medians are already given, and the question is about the area, okay. Can we draw the third median? And can we now say that the centroid divides your area of triangle into 6 equal parts, right? So 1, 2, 3, 4, 5, 6, all are equal areas. The area of triangle ABC is 108. If you divide that into 6 equal parts, it is 16. No, 18, right? So each of this triangle will have an area of 18. Now you want to find out the area of EOD. EOD. How do you do that? You know that this 4 can be split as 3 and 1, remember? Right. So EOD. Earlier there was 4 here. We split that as 3 and 1. Correct. This one is 18. We have to do similar thing here, which is splitting it as 3 and 1. Right. So this is 3/4 of 18. And this 18 threes are 54. 54 upon 4, that is 13.5. And the remaining is what? 4.5. So this 18, I can write it as 13.5, 4.5. Same way with this one, 13.5, 4.5. Can you now answer what is EOD? EOD is 4.5 plus 4.5, that is going to be 9. Okay, why it was 3:1? So this was the reason. Remember, this was 4. We were splitting it as 3:1. That was the reason that we discussed over that, right? Same reason over here. Now, suppose if you do not like this approach, if you do not remember this 3:1 thing, then we can solve it in another way also. ABC, medians are BD and CE. BD and CE. I'm drawing the third median. Let's say it is F. Okay. Now, can we use the midpoint theorem? Forget about the medians. Okay, right now. Can we use the midpoint theorem? What is the midpoint theorem? If you join the midpoints, the middle triangle will have an area which is 1/4 of the total area. Correct. We know that. So can we just take 1/4 of this? Total area is 108. 1/4 of that is 27, right? So I can say that now triangle EDF is having an area of 27. Triangle EDF has an area of 27. Agreed. Now, for triangle EDF also, these are the medians only. And this point is the centroid only, right? And therefore, I can say that this centroid, which is O, will divide your area of triangle EDF in 6 equal parts. So 27 upon 6, how much is that? 4.5. So each of this will be 4.5. This will also help you get the area of EOD as 9 only. A circle of diameter 8 inches is inscribed in a triangle ABC where angle ABC is 90. This is angle ABC, which is 90. Circle of diameter 8. Now, when diameter is 8, in radius must be 4. So this is 4. This is inscribed in triangle ABC where ABC is 90. Okay. Angle B is 90 degree. BC is 10. The area of triangle in square inches is how much? Now, how do you find out the area of triangle? Obviously, half into base into height. Correct. The base is given to you, but height is unknown, right? So how do we get that height? Obviously, I need to figure out the measures of the side. Correct. How do I figure out the measure of the side with the help of the in radius? We know the formula for the in radius, which is a plus b minus c upon 2. Correct. R is 4. A is unknown. This side is a, by the way. B is 10. C is unknown. And this is 2. So 4 2s are 8. That is equal to a minus c plus 10. Right? If I shift a and c on the other side, which is c minus a, and 8 on the right side, so it is going to be 2. Now I'm telling you that the difference of these two is going to be equal to 2 units. Are you able to use your triplet and find out the measure of these two sides, which will have a difference of 2, this being 10? So how do you think? How are you supposed to think here? You should think that uh, which triangle will have a 10 as one of the side, making right angle, and is also part of the triplet. So you know that there is something like 5, 12, 13. And the second multiple of it could be 10, 24, 26, right? So that is how knowing the triplet is absolutely important, so that you can come up with this combination almost instantly, correct? Now, this side is 10. The other two side will be 24 and 26, and they differ by 2, which is what we wanted, correct? So this is 26. This is 24. Now it's very easy for me to find out the area, which is half into base, which is 10, height, which is 24. So it should be 120. In triangle ABC, BCA is 50. This angle is 50. D and E are points on AB and AC. Respectively, such that AD is equal to DE. AD is equal to DE. Okay. So just a minute. I'm going to show this in this manner. AD and DE are equal, right? F is a point on BC. F must be a point here. such that BD equal to DF. BD equal to DF. Okay. So this is BD and this is DF. These two are equal as well. Measure of FDE is how much? You want to find out this angle. If you remember, we have done similar question earlier, right? So I'm just going to follow the exact same approach. These two sides are equal. Therefore, their opposite angles are equal. Take them as X. This is X. This is also X. So this is going to be 180 minus 2X, right? Same way, these two sides are equal. Their opposite angles are equal. Take them as Y each. So this is going to be 180 minus 2Y. Now you know that from the original triangle, you know that A plus B plus C is 180. A being X, B being Y, C being 50 is 180. So X plus Y is 130, right? Now after that, you can take this missing angle as Z, and you can see that they all are on the same straight line, isn't it? These three angles, 1, 2, 3, are on the same straight line. So their summation is going to be 180. So 180 minus 2x, this is the first angle over here. This is the second angle, which is Z. The third one is 180 minus 2y. Their summation is going to be 180. So 180 minus 2x minus 2y plus z equal to 0. And therefore, z is equal to, shift everything to the right side, that is 2x plus 2y minus 180. You know x plus y is 130, so twice of that is 260 here, minus 180. This is going to be 80. If you remember, we did almost similar question. The only difference was our triangle was right angle. Over here, it is 50-degree angle that is given. In triangle ABC, medians AD and BE are perpendicular to each other. I think we discussed similar question to this as well, where medians were perpendicular, isn't it? AD perpendicular to BE. This is AD, this is BE. There is 90-degree here. And they have length of 12 and 9. So AD has a length of 12. Can we split AD as 2:1, 8 and 4, right? So this has to be 8, this has to be 4. Similarly, BE has a length of 9. Let's split that as 2:1, 6 and 3. This is 6, this is 3. Now, if this is 6, this is 8, and there is 90-degree, which means the hypotenuse is 10. 6, 8, 10. Okay. The area of triangle ABC is how much? Okay. So we can find out the area of triangle. In fact, this 10 is not needed. I can simply concentrate on this triangle. And find out its area using half base height. How much is the base? 6 plus 3, that is 9. Into height, which is 8. 9 is a 72 upon 2, that is 36. Okay. If this one has an area of 36, this one will also have an area of 36, totally 72. Median divides the area of triangle into two equal parts. Two ships, they are approaching a port along straight route at constant speed. Initially, the two ships are and the port form equilateral triangle, right? So I think this is where you can start drawing, making the diagram. Two ships and the port make equilateral triangle. So this is your port, this is your ship 1, ship 2, they make an equilateral triangle. Hence, this angles are 60 each. And the sides are also equal, which is 24. So this is 24 kilometer, 24, 24. When the slower ship, let us assume that S1 is the slower ship. S2 is the faster one. When the slower ship traveled 8 kilometer, so when this ship reaches over here after traveling 8 kilometer, is the new location of that ship, S1. The triangle formed by the new position of the two ship and the port became right-angled triangle. Now, obviously, we have considered this to be slower. So this has to be faster, and therefore faster one will travel more distance. So in the same amount of time, let's say S2 has traveled little more distance than S1. And they have reached at a point where it makes an equilateral triangle, right angle triangle. Yeah. Okay. So now, as you can see, S1P S2 is a right angle triangle. I'm putting a 90-degree here. Correct. Now see, this is 8. Total was 24. This is 8. This must be 16. Now, can you see a 30, 16, 90 triangle getting formed here? See, this is 60 because it was equilateral, right? This is 90 because now it is a right angle triangle. And this is 30. So can we now apply 30, 60, 90? Side opposite to 90 is a 16, as you can see. So side opposite to 30 has to be half, which is 8 kilometer, right? Now, when the faster ship reaches the port, the distance in kilometer between the other ship and the port will be how much? So this tells me that for S2, only 8 kilometer remains, which means S2 has already traveled 24 minus 8, which is 16 kilometer, right? So if I just find out the distance that they have traveled, S1 and S2, in the same amount of time. S1 has done 8 kilometer, S2 has done 16 kilometer. The ratio of the speed is 1:2, right? Now read the last line of the question. When the faster ship reaches the port. So how far is the port? 24. If the faster one is reaching the port, which means when it is traveling 24 kilometer, the slower one, according to the ratio of 1:2, would have traveled only 12. Correct. So how far it is from the port? Because out of 24, it would have traveled 12. So it will be 12 kilometers far from the port. So I think this question is a beautiful application of 30, 60, 90 triangle, right? No, they are saying that, okay. See, I'll cover this part again. First of all, this is what you have. 60, 60, 60. Okay. S1 is slower, S2 is faster. They start simultaneously. By the time S1 covers 8 kilometer, which means the remaining distance for S1 is 24 minus 8. So can we write this as 16? Correct. S2 is able to make a right angle triangle. Now that is a very, very, very important data. S2 makes a right angle triangle. So S2 should be somewhere here so that there is 90-degree formed, right? And therefore, if you now focus only on this part, it gives you 30, 60, 90. Correct. With the side opposite to 90-degree angle being 16, and therefore side opposite to 30-degree must be 8, right? So for S2, if 8 kilometer remains, this is remaining, no? So how far they have traveled? S1 has traveled 8, and for S2, if 8 is remaining, it would have traveled this much, which is 16, right? So then I can take the ratio of the traveled distance for S1 and S2. S1 has traveled 8 and S2 has traveled 16. So 8 is to 16 is 1 is to 2. So the speed ratio is 1 is to 2. Now they are asking me if S2 reaches the port, which means when S2 completes 24. So S1 would have done exactly half. It would have done 12 according to the ratio. So for S1, if 12 is done, 12 is remaining. And therefore it has to be option 4. Regular polygon A and, okay, how is this question here? It should be in polygons. Okay, I'm going to shift this in polygon, right? We need to discuss the polygon related formulas for this, right? So I'm going to shift this slide in tomorrow's presentation. In a rectangle ABCD, AB is 9. This is 9. BC is 6. P and Q are the points on BC. So on BC, you have 2 points, P and Q. Such that area of ABP, this is your ABP, then APQ, this is APQ, and AQCD are in geometric progression. Okay, what is geometric progression? APP, that is one area. APQ is the second area. And the third one is AQCD. They are in GP. Now, when the areas are in GP, the ratio is constant. Okay, there is a constant ratio between these two as well as these two. The area of the figure AQCD is 4 times that of triangle ABP. So for ABP, if you assume that the area is X, this has to be 4 times, which means it is 4X, right? So the middle term, for the ratio to be equal and this to be X and this to be 4X, that has to be 2X, no other choice, correct? So that this will have a ratio of 2 by 1 and this will also have a ratio of 2 by 1, correct? So this is how you have a ratio constant, which is GP. So the last one is 4 times the first one. The middle one has to be 2 times, correct? Now, one very important property that you need to know is that if heights are equal, then the ratio of area should be same as the ratio of the base, which is very obvious also, as your area can be given by half into base into height. So if you take height as constant, then area will directly vary as base, right? So base doubled, area doubled, base half, area half, and in whatever ratio you are taking your base, the ratio of area will follow the same, right? Now over here, I can say that, see, look at this ABP and APQ. If I'm showing you the triangles in this manner, this is your ABP, right? So for triangle ABP, what is my height? Height is always something which is perpendicular from the opposite vertex, right? So height is AB. This is for ABP. Now for APQ, if I'm asking you what is the height, again, it is the same height, which is AB, right? It is not that the height is always inside the triangle. You cannot draw a height which is not at 90 degree, right? And therefore, even for triangle APQ, your height is something which is at 90 degree from A, and that has to be AB only, right? which means the heights are equal for ABP as well as for APQ, right? For both these triangles, the height are equal. If the heights are equal, then the area ratio will be same as the base ratio, correct? So what is the area ratio between these two? 1:2, which means the base are also in the ratio of 1:2. So if you take this as 1, this can be 2, right? You can take this as K also, 1K and 2K, not a problem, right? And I'm putting the areas also, which is 1x here, 2x here, and 4x here, right? So looking at this 1x, 2x, and 4x, what do you think is the total area of the rectangle? Definitely it is 7x. Simply the addition of 1, 2, and 4, the total area is 7x. Okay. Now, when you know that the total area is 7x, if you draw a diagonal, that is going to divide the entire 7x area into two equal parts, like 3.5x and 3.5x, correct? So, I can say this 4x will now get divided as 3.5x here and 0.5x here. So, on either side of the diagonal, you will have 3.5x area. You can check this. This is 3.5x. This is also 3.5x. Now, if this is the ratio of your areas, that is x, 2x, and 0.5x, right? Then the ratio of base is also the same. That is what we have discussed already, correct? So the ratio of base is also 1K, 2K, and this is 0.5K, correct? And that is what which has been asked for. Look at this. BP is 1K. PQ is 2K. And CQ is 0.5K. You can cancel K everywhere. So the ratio is 1, 2, and 0.5. And you can multiply this ratio by 2 to convert everything in integer. So this has to be 2, 4, and 1, which is my final answer. 2, 4, and 1 is option number 1. Yes, after taking equal height, if the heights are equal, the ratio of the base will follow the ratio of the area. Basically, these two are the same, right? So in whatever ratio my area is given here, that is 1, 2, and 4. Okay, so this is 1, this is 2. And I earlier wrote this as 4x. Both these combined is 4x, right? Later on, I ended up drawing a diagonal AC. And then I said that, okay, you draw a diagonal. So the total area, which is 7x. How do we get 7x? Obviously, x plus 2x plus 4x was 7x, right? So this 7x, when you draw a diagonal, that gets divided into two equal parts, which is 3.5 and 3.5, right? So on either side of this diagonal AC, we will have an area of 3.5x. So that gives me x 2x. This was already 3x, and hence this was 0.5x. So if the areas are in the ratio of 1, 2, and 0.5, the sides are also in the ratio of 1, 2, and 0.5. The same ratio I've written here, and I've converted that into integer. Yeah, but that is not the triangle. That is what you need to understand, Alpana, right? A, B, C, Q. It is not a triangle, right? The property is valid for triangle. Now, ADCQ is a quadrilateral, right? So that's why we're not applying that. You have to convert that into triangle, and then you can apply the property. So when it converts into triangle, the area is only 0.5x. When the area is 0.5x, the side is also in the same ratio. In a right angle triangle ABC, the altitude AB is 5. This is 5. Base BC is 12. P and Q are 2 points on BC such that area of ABP ABQ and ABC are in AB. If the area of ABC is 1.5 times the area of ABP, this is 1.5 times of this, right? If you take this as X, this is 1.5X. And this is in AP, correct? So AP is where the difference is constant, right? So obviously the overall difference is 0.5 that you will have to divide as 0.25, 0.25. So this is going to be 1.25X. These are the areas, right? Now, instead of keeping X 1.25X and 1.5X, if I make an attempt to convert everything in integer, I can multiply this thing with 4, right? It's ultimately the ratio that I'm taking. Okay. So instead of X is to 1.25X is to 1.5X, I can multiply everything by 4 and I can write the ratio in a slightly better manner, which is 4X, 5X, 6X. Okay. Now, ABP has an area of 4X. Then ABQ, this has an area of 5X. And this has an area of 6X. Now, just a minute. See, this is 4X, correct? Then this is 5X. So this is ABP and this is ABP and then Q, right? So 4X is part of a 5X. I hope you understand that, correct? 4X is a part of this 5X because 4X is only this much and 5X is this much, correct? So 4X is a part of 5X and that is why if I try to write the areas individually, I can say that, see, ABQ is 5X. Out of that, ABP is 4X, which means this is only 1X, correct? And then this ABC is 6X. So the total is 6X, out of which I already kept 4X and X, 5X here. So this has to be X, correct? Which means that my BP, PQ, and QC will also be in the ratio of 4 is to 1 is to 1 using the same property that we discussed in the previous question. That is, if the heights is the same, then ratio of area is same as the ratio of the bases. So if the ratio of area is 4, 1, 1, the ratio of bases is also 4, 1, 1. You see, it's a very similar question, isn't it? Now, can we divide 12 in the ratio of 4, 1, 1? It has to be 8, 2, 2, right? So this actual measure is 8 units, centimeter, 2 centimeter, and 2 centimeter. Now I can answer whatever length is required, that is of PQ. So PQ is this much, which is 2 centimeter is my answer. I hope you will agree that the ratio of 1, 1.25, 1.5 can always be written as 4, 5, 6. So these are the bases on which we multiplied 4. This ratio and this ratio is equal, isn't it? Yes. So what is AP? AP is where the difference is constant, correct? So if I know that one term is 1, the middle term is missing, and this term is 1.5, and if I say that this is AP, the middle term has to be 1.25. No. What is AP? The difference has to be constant. Yes, Harsh, if there are doubts, I have to solve, right? There are people who are not able to understand, so we need to clarify the doubts. This is 0.25. This is 0.25, correct? This is how it is AP. And that's what we have used here, 0.25x, 0.25x. Next question, D and E are the points on AB and AC respectively of a triangle ABC such that AD is to BD is 2:1. Let's try to draw a diagram here. AD is to BD. This is 2:1. So this is 2:1. You can take it as 2K and 1K. AE is to CE is 2:3. Okay, this is 2:3. Take this as 2x and 3x. Okay. The area of the triangle is ADE is 8 square centimeter. This is 8 square centimeter. Then the area of ABC is how much? Right. If you take this angle as let's say theta, right? How do you find out area of ADE? Can we say it is half into AB sine theta? I hope you remember the property. Half into this into sine theta. So 2K into 2x into sine theta. This is the area of triangle ADE. And we can also write the similar formula for area of the whole triangle, which is ABC. That is half into this into this. Correct. Which is 3K and 5x into sine theta. Take their ratio. So sine theta is cancelled. This K is cancelled. X is cancelled. Half is cancelled. So you are having 2 into 2, 4. 3 into 5, 15. Area of ADE is given as 8. The only thing which remains is area of ABC, and that has to be 30 using the ratio here. Let ABC be a right-angled triangle with hypotenuse BC of length 20. BC is the hypotenuse of length 20. This is A, which is right angle. And AP is a perpendicular on BC. This is AP, perpendicular. Right? Altitude on hypotenuse, you can say. This is perpendicular, and you have to find out maximum possible length of AP in centimeter. AP needs to be maximized here. What is the formula for AP? AP is altitude on hypotenuse, which is A into B upon C, right? C is given to you as 20. So AB upon 20. This is what we are looking for. Now, how to maximize this AB? We know that because it's a right angle triangle, A square plus B square is equal to 20 square. Correct. So if I want to maximize the product of A and B, see, in order to maximize AP, which is given as AB upon 20, I have to ultimately maximize AB. How do I maximize AB? So if I know that A square plus B square is 20 square, how do I get the maximum value of AB? Maybe I can write A square plus B square as 400, right? And take equal value for A and B. Whenever A and B are equal, AB will be maximized. That is what you know, right? I think we have discussed this during inequality also. So take A and B equal. That is where the product will be maximized. So because A square plus B square equal to 400, I can take each of them as 200, right? That's how the total is 400 and they both are equal. So if A square is 200, A is going to be 10 root 2. So is the value of B, right? They both are equal. Put that over here. 10 root 2, 10 root 2 divided by 20. So the 0 is out, and 10 into root 2 is nothing but 20 divided by 2, which is 10. This is the maximum value of AP. Yes, this is the previous slide. Okay, this was the last question for the day. We'll be having quadrilaterals and polygons tomorrow. Yeah, thank you. Isn't the circumradius the biggest perpendicular possible? No. Circumradius will be, having the same measure as the median, right? And median may not be perpendicular. So this is your circumcenter. And from there, if you join this, okay, this will be longer, no doubt, but this will not be perpendicular. That is the problem. And here we want AP to be perpendicular.